All right, so starting with problem number 9. And when you get to a problem that is similar to this on the test tomorrow, if it would be helpful to you to actually have some of these solids on your desk so that you can visualize it a little bit better, I am more than happy to do that. Just raise your hand during the test and let me know that you would like some of the solids, and I will bring those over to your desk. All right, so this first one, we have a cone shape. If I take and I cut this parallel to the base, I chop it off right here, and I look at that freshly cut side, what shape would I see? A circle. Now, if I were to cut perpendicular to the base through the point at the top, and I were to look at that freshly cut side, what would I see? Triangle. All right, my next shape is a cylinder. If I were to cut this cylinder parallel to the base and look at the cut side, what shape would I see? A circle. Right, this one's a little bit trickier. If I go perpendicular to the base and I looked at the freshly cut side, what shape would I see? What'd you say? Nope, it's going to be a flat two-dimensional object. So things like circles, squares, triangles. We're going to see a rectangle. When we're parallel to the base, we would see a circle. Here's what's going on with my rectangle. When I look at a cylinder, the left and the right are parallel. They're never touching. The top and the bottom are flat. They're never touching. So if I were to take that cylinder and slice it vertically, like this, left and right are parallel, top and bottom are parallel. That's going to give me a rectangle. Since I can't actually cut through this cylinder right here, I could also look at like what kind of a shape would the shadow be. If I were to have a light behind this and it were to project a shadow on the wall, I would see a rectangle shape. I wouldn't see the circles in that shadow. I would just see the flat top, the flat bottom, and the flat left and right sides. All right, then we get to our last shape. How many sides do the bases have? 6 sides. What do we call a 6-sided shape? Hexagon. So this is a hexagonal prism. If I were to cut that hexagonal prism right through the center, parallel to the bases, what shape would I see? Hexagon, yes. Whenever we talk about cutting parallel to the base, whatever the shape of the base is, that's what I'm going to see when I make that parallel cut to the base. This one, I'm able to show that perpendicular to the base shape a little bit better. So if I cut this one perpendicular to the base, straight up and down like this, I'm going to actually show you on this hexagonal prism right here. I can deconstruct this. So if I cut it in half, do you guys see my shape there? What shape is it? It's a rectangle. Flat top and flat bottom, flat left and flat right. Parallel here, parallel here. So we get a rectangle. Does that help a little bit seeing it on this one? Cylinder is going to be the exact same thing. It does not matter what shape the bases are on these prisms. Whenever we cut perpendicular to the base on a prism, we're going to see rectangles on that cut side. All right, the next one I was asked for was number 7. Number 7's on the previous page. It says Eakin Sports Goods is trying to create a new line of golf equipment. They're packaging a sleeve of 4 golf balls in a cylindrical can. If the golf balls with diameter 42.6 millimeters lie flush against the sides, top, and bottom of the can, then find the amount of unused space inside the can. What does it mean again when it says that it lies flush? Yep, it's a tight fit, but it's a perfect fit. Like you didn't have to squeeze, no sides are bulging, but it just fits perfectly right down in there. And we know that the diameter is 42.6 millimeters. Do we use diameter in any of our formulas? No, but what do we use that we're going to need here? The radius. Radius would be 42.6 cut in half. What is half of 42.6? 21.3 millimeters. Perfect. All right, so from the center of the ball over is 21.3 millimeters. But we said we know the diameter is 42.6. Diameter goes edge to edge through the widest part, right? That'd be 42.6. How tall is the next ball? 42.6. And the next ball? 42.6. And finally, this fourth ball up on top is another 42.6. Why do I care about that? For the height of the cylinder, yes. So for the height of the cylinder, we have to do 42.6 times 4, which gives us what? 170.4. Right on the edge of the screen there. Okay. We want the volume of unused space. So what am I going to need to do if I want to calculate the volume of unused space? Yes. We're going to do the volume of the cylinder minus the volume of the 4 golf balls. Bless you. Do you need to step out and get some water? Okay. So let's calculate these things off to the side. We'll do the volume of the cylinder first. You're welcome. I'm actually going to bring that over here. Volume of the cylinder. How do we calculate volume for a cylinder? Yes, pi r squared times the height. What is the radius of this cylinder? 21.3. So I have pi times 21.3 squared times the height, which is how much? 170.4, yes. What do we get for that volume? Yep. 242.872. You said 0.6827? So we'll call it 683. Sound good? And that would be millimeters cubed. All right, so that's the number that we need right here. 242.872.683 minus, now we need the volume for the 4 golf balls. We're going to do volume for 1 golf ball. How do we calculate the volume for a golf ball? Yes, 4/3 pi r cubed. So we only need 1 dimension to put in here, just the radius. So I'd have 4/3 pi times what cubed? 21.3 cubed. What is 4/3 pi times 21.3 cubed? All right, hold on. You said 40,000 what? Perfect. 40,478.780, so I'm just going to leave that as 0.78. So then the volume for 4 golf balls, I would do 4 times 40,478.78, and that gives us what? 161,915.12, and that would be millimeters cubed. So from this 242,000 something, we're going to subtract off 161,915.12. And what do we get when we do that subtraction? Like that? Did I do it right? Okay. Millimeters cubed. If your decimals are a little different than mine, does that mean that you get it wrong? No. I need to see your work. Show me what you're plugging into the calculator. As long as you are grabbing the right things to plug into your calculator, if your decimals are a little different than mine because you rounded a little differently than me, that is not going to be a problem at all. You will still get full credit for the problem. All right. What else would you guys like to see? Yes. Number 8, absolutely. You with me, dear? We're on number 8 now. Some brands of pantyhose package their hose in containers that have a cylindrical bottom and a hemisphere top. If the hemisphere and cylinder have a diameter of 3 inches and the cylinder has a height of 2 inches, then find the total surface area, bottom, sides, and top, and the volume of this container. All right, so we have a diameter of 3 inches. What am I going to do with that? Cut it in half. If the diameter is 3 inches, then the radius is what? 1.5 inches. So that's going to go from the center of the circle over to the edge, 1.5 inches. Thank you. And when I'm looking at my hemisphere top, it would be 1.5 inches to go from the center to the edge this way or this way. Because it's a hemisphere, the radius is the same in all directions, as long as I'm going from the center. And then we have the height of the cylinder at 2 inches. So this right here is 2 inches. We want the total surface area of this object, and we want the volume. So let's calculate surface area first. For the surface area, I need the base, the bottom. What shape is the base? A circle. How do we calculate area for a circle? Pi r squared. So I'm going to need pi r squared for my base, plus, now I need the body of the cylinder. That's my lateral area. That is perimeter times height. What do we call the perimeter of a circle? Circumference. How do we calculate circumference? 2 pi r. So 2 pi r and then times the height. I'm going to label what we're doing as we do it. This is area of the base. This is the lateral area of the cylinder. And now we just need that hemisphere top, right? And we're talking surface area. How do you find surface area for a whole sphere? 4 pi r squared. So what would I do for a hemisphere? 2 pi r squared. This right here is the hemisphere top. All right, so now we are ready to substitute in. Yep. Yes. Of the hemisphere, that's a good question. Is that on the surface of this object?
No, which is why I'm asking.
That's okay. So looking at the outside of this thing here, if we're talking surface area of a cylinder, normally we have two bases to worry about, right?
Yeah.
So it'd be 2 times the area of the base plus the perimeter times the height. Well, one of my bases is down here. I want that. The other base is right here, which is now in the middle of my shape. So I just want the one circle-shaped base. That's what this pi r squared is right here.
For the hemisphere.
Mm-hmm.
For the sphere itself to be, never mind. I got it now.
That's okay. Yeah, that's the sphere, because the sphere doesn't have a base on it, I don't have to worry about removing that. That's a good question. If this was a pyramid or a cone on top, then I would have to worry about not including that. But a sphere, because we don't have any bases here, if I cut it in half, it's not including any bases. Good questions and thoughts there. All right, so we do pi r squared, which is going to be pi times what? Pi times 1.5 squared. What do we get if we just do that part? Pi times 1.5 squared. No. 7.069 plus 2 pi times our radius of 1.5 times the height of what? Height of 2, yes. So 2 pi times 1.5 times 2 would give us 18.849 plus 2 pi times my radius of 1.5 squared. What do we get for just that part? 14.137. Then we add all 3 of those together to get our total surface area. What is our total surface area? You said 40.055? Surface area is 40.055. What kind of units should we put with that? Inches squared, yes. All right, so there's my total surface area. Now we need our total volume. Volume is going to be volume of the cylinder plus volume of the hemisphere. How would we calculate volume of the cylinder? Yep. Pi r squared times the height plus, for the hemisphere, what would I do? 2 pi r squared would be surface area for my hemisphere.
2/3 pi r cubed?
Yes, 2/3 pi r cubed. Remember, for a whole sphere, it's 4/3 pi r cubed. So for half of a sphere, it is 2/3 pi r cubed. The 4's become 2's whenever we take a sphere and cut it in half for both surface area and volume. All right, so I have volume equals, now we have pi times our radius of 1.5 squared times the height of 2. Let's go ahead and pop just that much into the calculator. What do we get there? Yep, 14.137 plus, now we do our hemisphere, 2/3 pi times the radius of 1.5 cubed. Do you guys remember how to put in the cubed into the calculator? What button do we push? The caret right here. It looks like an arrow right above the x squared key. What do we get when we do 2/3 pi times 1.5 cubed? 7.069, and then we add those two together to get our total volume. 21.206, and that would be inches cubed. Very, very nicely done. What else would you guys like to look at? Yes. Number 11? Absolutely. Number 11. A rectangular box contains 3 balls which lie flush against all the sides. The volume of one ball is 14.137 cubed inches. Part A of this question says, what is the radius of one ball? The only thing they gave me to work with here was volume, right? So what formula am I going to have to use? Have to use volume. Volume for a ball would be what? 4/3 pi r cubed, yes. And we're going to take this volume here, we're going to put it in the place of the V. So 14.137 equals 4/3 pi r cubed. I see a fraction. I do not want a fraction as I'm trying to solve this. What operation gets rid of fractions? Multiplication. What part of the fraction do you multiply by? By the denominator. What's in the denominator of our fraction? A 3. So we multiply both sides by 3. Now, over on the right, when I multiply by 3, the 3 that I multiply by and the 3 in the denominator cancel each other out, which means it can't do anything to the 4 up on top. Because it canceled, it now has no power over anything else. It does not multiply by the 4. It only cancels with my denominator. So over on the right, I have 4 pi r cubed. What do I have on the left? 42.411. And now we're going to solve this for r. So what's my next step? Divide both sides by 4, yes. What is 42.411 divided by 4? 10.602. Yep. You said 27? Yeah. Why don't we round that to 3? 10.603 equals pi r cubed. If you rounded that to 10.602, you're not going to miss any points on the test. It is perfectly fine. I, however, need to bring my work around here. 10.603 equals pi r cubed. What do I want to do now? Divide both sides by pi, yes. What is 10.603 divided by pi? 3.375 equals r cubed. If that was a squared instead of a cubed, what would we do to get rid of the squared? Square root. So what do I do to get rid of a cubed? Cubed root. Looks just like a square root, except it's got a little 3 out in front of it. Looks just like a square root, has a little 3 out in front. Squared and square root cancel each other out, so cubed and cubed root also cancel each other out. So I have just r on the right-hand side. Do you guys remember how to put a cubed root into the calculator? Right. Quick going over of the directions for that again, just in case you've forgotten. The first thing you have to do if you're going to put a root into the calculator that's not a square root is you got to tell it what the root is. So the first thing we're going to do is type in the 3 because we want it to do a cubed root. After you push the 3, you push second and that caret key again. That's going to take the 3 that you typed in and it's going to make it just a little bit smaller and put it right in there in the little crook of the square root arm. And then we're going to type in 3.375 and hit enter, and we get what? 1.5. 1.5 what? 1.5 inches. Nice work. Yes.
Different numbers.
Okay, so you did not hit the second before you hit this, you just hit this key. You have to hit second and then that key. Nope, that one. There you go.
Thank you.
You're welcome. All right, so 1.5 inches for the radius. So that means from the center of the ball to the edge, it is 1.5 inches. The same thing is true if I were to go straight down. That would also be 1.5 inches. Part B of this question said, what are the dimensions of the box? So we want the length, the width, and the height. If that ball is 1.5 inches from the center to the edge, how wide is it at its widest point? 3 inches, yes. What about the ball next to it? 3 inches. And the ball next to that? 3 inches. So we would do 3 times 3 inches. How long is the box? 9 inches. How wide is the box? 3 inches. Because it is one ball wide. How tall is the box? 3 inches. Because it is one ball tall. Yes. No. This time, the width and the height are the same because it is only one ball deep and one ball high. But if there was 6 balls in here instead of 3, and so we had them stacked up twice as tall, then the height would be 6 inches instead of 3 inches. Does that make sense? Yeah, it all depends on how many balls are inside. So how many times do you have to look at that diameter? What else would you guys like to see? Which one? 13, absolutely. Thank you. Number 13. Cameron bought a birthday gift for his friend Jay. He placed it in the box pictured below. How much room is there inside the box for the gift? If I am asking about space inside an object, what am I asking about? Volume. Tomorrow on the test, it is absolutely fair game for me to ask a question like this and to expect that you know that that means volume. I will not be able to tell you on the question like this that what I'm looking for is volume, because one of the things I'm assessing is, do you know that volume is the space inside? Do you know that surface area is the outside of the object? All right, so how much room is inside the box for the gift? So I need volume here. What shape is this box? It's not a rectangle, but you're close. A rectangle is a flat shape. We have a 3-dimensional object here.
I found this on the web.
Thank you, Siri. Yes, it is a rectangular prism. How do we find the volume for a rectangular prism? Area of the base times the height. Now I have noticed on several of these problems that people will put in side squared for this. That only works if your base is what shape? A square. Is the base of this box a square? No. What shape is the base? It's a rectangle. Now I can look at this as the base, or because it's a rectangular prism, I could also look at this as the base, or I could look at this as the base. With a rectangular prism, it does not matter which face you choose to look at as the base because it's all rectangular faces. I'm going to go with this because to me, base indicates bottom. And since I can go with any direction I want to, I'm going to do this. How do we find the area of a rectangle? Yep, length times width, which is basically base times height. So we have length times width times the height. So if I'm looking at this base right down here, what are the length and the width of this base? 10 and 5. So here's my length, and here's my width. If you did those two the other way around, it's perfectly fine. It does not matter which one you call the length and which one you call the width. So I have 10 times 5 for my length times width. And now I need the height of the whole prism. If 10 and 5 are the length and the width, what is the height? The 2, right here. That is this piece. That is the height of the prism. So I have 10 times 5 times 2, which gives me a volume of what? 100. What units should I put with that? Centimeters cubed, yes. How much wrapping paper will Cameron need to wrap the gift? What am I asking about now? Now I'm asking about surface area because the wrapping paper goes on the outside. Yes. Yep. Difference between surface area and the lateral area. So surface area is everything you see on the outside, right? So on this one, it includes all of the triangles and the square on the bottom. On this object right here, it includes my 2 hexagons and then all of those rectangles around the sides. Lateral area is the same thing as surface area, but minus the base. So on my pyramid here, it would be just the triangles. I would not include the square that's on the bottom. On this hexagonal prism, the lateral area would be just these rectangles around the sides. That would be the perimeter times the height. I would not include those 2 hexagon bases. Does that help? Good. All right. So we want the entire surface area because we're going to cover the whole box. Lateral area, I would not be covering the whole thing. How do we find the surface area for a prism? Yes, 2 times the area of the base plus the perimeter times the height. You guys already told me that the base is a rectangle, and we find the area of that rectangle by doing length times width. So I would have 2 times the length and the width. We said were 10 and 5. What do I get when I do 2 times 10 times 5? I get 100. So 100 plus the perimeter times the height would be the lateral area. To find the perimeter, this has to be the perimeter of the base. Has to be perimeter of the base. So I'm going to look at that base. We're going to go all the way around it. So this side is 10. How big is this side over here? 5. So 10 plus 5 plus how big is it back here? That'd be 10. Plus this left side over here, which is how big? Another 5. So 10 plus 5 plus 10 plus 5 would give me a perimeter of what? 30 centimeters. So we're going to take that 30, we're going to put it in for P. And then height is the height of the prism, which we said before was how big? 2. And 30 times 2 gives me 60. So I add those two together, and I get a total surface area. Yes, 160 centimeters squared. All right, we have 5 minutes until the end. Yes? No, that's a good question. The larger the object gets, the larger the volume gets, and surface area doesn't keep up that pace because volume is cubed and surface area is squared. So the smaller the object, you're going to have a smaller or a larger surface area than you do volume. But the larger the object, you're going to have a larger volume than surface area. I do have enough time for a short one if anybody wants to see a short one. Yes. Yes, I can do number 12. Give me just half a second, because somehow that one got left out of here. Right, number 12. I don't know how I managed to miss this one. Find the surface area and volume of a soccer ball if the diameter of the ball is 29 centimeters. What do I need to calculate from here? Radius. If the diameter is 29 centimeters, how big is the radius? 14.5. All right, we want volume and surface area. How do I calculate the volume for a soccer ball? That'd be for a circle. 4/3 pi r cubed. So I would have 4/3 pi times 14.5 cubed. And when I pop that into my calculator, I get 2,642.079 centimeters cubed. And then it also wanted surface area. How do we calculate surface area for a ball? Yep, 4 pi r squared. You're absolutely right. So we do 4 times pi times that radius of 14.5 squared. Pop that into the calculator. 4 times pi times 14.5 squared. Oh, shoot, I did that wrong. I wrote the volume down as the surface area. I apologize, guys. I looked at the wrong spot on my answer key. This is the one that's 2,642.079, and that would be centimeters squared. The volume, and I apologize for writing this down wrong the first time. I got 12,770.051 centimeters cubed. I apologize for that. Answer key is already posted in Canvas. Just underneath where I went and got this is where you can find that answer key at. So I'm going to go ahead and make this smaller and clear this out. Head back here. If you scroll down to the very bottom, right down here where it says solutions, if you click on that, you can see all of my work for all of the problems. Videos will be going up throughout the day, with the first ones going up here within the next hour, and then they will matriculate throughout the rest of the day as my videos finish rendering. Don't forget, you will be turning in this test review tomorrow. This will be the next to last thing you turn in to me. All right.